7. Sourdough bread.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Hadfina Aisha Binti Azari, and my metric number is TN220100. So I will present the introduction of sourdough bread. So what is sourdough? Sourdough is the fermentation of a wheat and water mixture, sometimes with additional ingredients added, that is mostly made up of yeast and lactic acid bacteria, which is LAB. So LAB are mainly responsible for the dough acidification, which lowers the pH and prevents infections and spoilage organisms. While for the yeast, leaven the dough by generating carbon dioxide. So this interaction produces beneficial metabolites that improve the bread's flavor and texture while also providing a number of health advantages. So what is backsloping? So backsloping is the process of starting a sourdough fermentation by inoculating a fresh batch of flour and water. So the kinds of flour use the temperature, the degree of hydration, and the length of the fermentation process are some of the variables that affect this technique's performance. So in comparison to regular bread, sourdough fermentation involves the production of bioactive compounds like bacteriokins, which is have been demonstrated to improve the gastrointestinal and enhance mineral bioavailability. Next is the process flow diagram, which is PFD. So this is we draw the process, which is how we want to make the sourdough bread. So first of all, we use a bioreactor. So we introduce the flour, water, and the microorganism, which is lactic acid bacteria, and then yeast as a starter culture. And then we add on also the oxygen, which is it will produce from the sphager. So it will be mixing by the impeller in the bioreactor at temperature which is below than 30 degrees Celsius, and then fermentation time which is 6 until 24 hours, and also we have a dough yield and also oxygen. And then it will go through to the liquid sourdough. So the sourdough will be in the liquid phase, and then go through to the spray drying by the pump. So and then after the spray drying, it will go through the dried sourdough. So the sourdough is ready to use. So let's like I said just now, which is the we have I think six process. So first is ingredient mixing, which is we have one, two, three, and four ingredients to be mixing in the bioreactor, which is flour, water, NAB, which is lactic acid bacteria, and yeast starter culture. And then we go through to the next process, which is bioreactor fermentation. So there are a few of parameters, which is it will undergo under the temperature, which is 30 Celsius, and fermentation time 6 until 24 hours, and also have a dough yield and oxygen levels as a control, and also sparges, which is introduces the oxygen. And then the next process is liquid sourdough production, which is the sourdough in the liquid phase.
This liquid sourdough is then pumped from the bioreactor to the next stage, which involves spray drying. The spray drying equipment will dry the liquid sourdough by spraying it into a hot air chamber. In this chamber, the liquid is atomized into fine droplets that come into contact with hot air, causing the moisture to evaporate quickly and leaving behind dry sourdough particles. The dry sourdough is collected at the end of the spray drying process. This product can be stored for extended periods without spoiling. Finally, the dry sourdough can be packaged for distribution and later used in baking or other culinary applications. So this process efficiently transforms a mixture of flour, water and microbial cultures into a dry sourdough product through controlled fermentation in a bioreactor, followed by spray drying. So the key factors in this production, such as temperature, fermentation time and oxygen levels, is to ensure the quality and consistency of the sourdough. Next, this is the stir tank bioreactor that we use in sourdough bread production.
The improvement on the technology of sour bread is by real-time monitoring of sourdough bread fermentation using panigraph with an Arduino-based data acquisition and management system. The purpose of panigraph is to monitor various parameters during the fermentation process, including dough rise, carbon dioxide and ethanol release, reduction in pH, and conductivity of dough. How does the panigraph works? First is the sensor installation. The panigraph system includes various sensors that are installed in the fermentation environment, continuously collect data on these parameters, which is then transmitted to the panigraph system. Next is the data processing and storage. The panigraph system processes the collected data using software developed for this purpose, performing calculation and conversion as needed. The processed data is stored in a database for further analysis. The third one is the graphical representation. The panigraph system generates graphs that facilitate visual comparison of sourdough fermentative performance. This graphical representation make it easy to identify trends and patterns in the fermentation process. The last one is the monitoring and analysis. The panigraph system allows for real-time monitoring of the fermentation process, enabling bakers to track the progress and make adjustments as needed. The data collected can be used to analyze and optimize sourdough bread production. Lastly is the benefit of this technology. The panigraph system provides real-time monitoring and analysis of the fermentation process, enabling bakers to optimize their sourdough bread production. Second one is by identifying trends and patterns in the fermentation process, bakers can make adjustments to factors such as temperature, humidity and yeast activity in order to improve efficiency and reduce waste. The last one is the panigraph system help bakers produce high-quality sourdough bread by providing detailed insight into the fermentation process and enabling them to optimize their production methods.
I will explain an improvement on genetic engineering for sourdough bread production. As for the introduction, the genetic engineering tool that I will explain is a gene editing tool called CRISPR or Cas9 technology, which can be used to change particular genes inside an organism genome. It also has been used to enhance the nutritional value, gluten-free qualities, and quality of sourdough bread manufacture. Now, let's see the applications in sourdough bread production. First is gluten-free sourdough. By modifying the genes in wheat that produce gluten, CRISPR or Cas9 can be utilized to produce gluten-free sourdough bread. Second, nutritional enhancement. By adding genes that boost the production of advantageous chemicals, CRISPR or Cas9 can be utilized to raise the nutritional value of sourdough bread. Third, enhanced fermentation. Dough consistency, CO2 generation, and retention can all be increased by using CRISPR or Cas9 to improve fermentation conditions. Fourth, selection of starter cultures. To ensure consistent and superior bread production during sourdough fermentation, CRISPR or Cas9 can be utilized to select and optimize starter cultures. And the last one is co-culture system. Sourdough bread's quality and shelf life can be increased by creating co-culture systems with a variety of microorganisms used CRISPR or Cas9. For the challenges and future directions, the first one is delivery of CRISPR cargoes, in which efficient delivery of CRISPR cargoes into plant cells remain a major obstacle. Second, regulations where strict regulations governing gene editing technologies such as CRISPR or Cas9 may prevent their general adoption and commercialization. And the third one is public perception and acceptance. The public frequently express doubt and worries about gene editing technologies such as CRISPR or Cas9, necessitating ongoing outreach and education initiatives to guarantee popular acceptance.
So next part is for an improvement in bioreactor design is we can add user interface and control. So user-friendly interface, which is design and intuitive user interface for control system, allowing operators to easily monitor and adjust parameters. Other than that is remote access. So this is to enable remote monitoring and control capabilities so that the bioreactor can be managed from off-site location, improving flexibility and response time. The next is important factors affecting bioreactor function and its efficiency. So the first factor is monitoring and control, which divided into two, which is real-time monitoring and automation. So for real-time monitoring, use of sensors to monitor key parameters. For example, like pH, temperature, and so on, allow for real-time adjustment to maintain the optimal condition. For automation, automated control system can enhance consistency and efficiency by precisely managing environmental condition and feeding schedule. So the next factor is nutrient composition, which is substrate quality and supplementation. For substrate quality, the type and quality of flour and water used can affect the availability of nutrient for the microorganism. For supplementation, addition of nutrients such as vitamin, minerals, amino acid can enhance microbial growth and activity. So the next factor is mixing and agitation. So for uniform distribution, adequate mixing ensures uniform distribution of microorganism and nutrient throughout the bioreactor, leading to consistent fermentation. Shear force, while mixing, it's important to avoid excessive shear force that can damage microbial cells or alter their metabolic activity. So the last factor is fermentation time, which is duration. The duration of fermentation affect the development of flavor and the texture of the bread. Properly managing fermentation time is crucial for achieving the desired product characteristic. So the next part of this report is safety and regulation. So the first safety and regulation is CGMP. So Food Safety Act 1990. The Food Safety Act 1990 and subsequent regulation cover all operation involved in selling, processing for sale, delivering, preparing, labeling, storing, importing and exporting food. The next safety and regulation is HACCP, which is risk assessment. Conduct a risk assessment to identify potential hazard and critical control point in the sourdough bread production process. And the last one is additional regulation, which is gas safety, installation and use regulation 1998. Ensure gas appliances are properly installed and serviced by a gas safe registered engineer. So that's all from us. Thank you.